Think about a simple sheet of paper. It's something we see and use every day without giving it much thought. It seems so ordinary, right? Just a thin, flat object. Now, imagine folding it in half. A simple action, but let's see what happens next. Fold it again and again. What happens? Each time you fold, the paper's thickness increases. The paper's thickness doubles with each fold. It starts to become noticeably thicker. This simple action holds a powerful secret, the magic of exponential growth. With each fold, the thickness doesn't just add up, it multiplies.
Folding paper might seem like child's play, something we all did as kids, but hidden within this simple act are profound mathematical principles. It's a real-world example of exponential growth. Each fold doesn't just add thickness, it multiplies it. This is why the paper becomes so thick so quickly. This is the essence of exponential growth, and it can lead to surprising results. The more you fold, the faster the thickness increases. Imagine folding a piece of paper more than just a few times. Theoretically, with enough folds, the thickness could become astronomical. With enough folds, you could theoretically reach incredible heights. The paper could become as tall as a building. Could we even reach the moon by folding a single sheet of paper enough times? Let's find out. Theoretically, it would only take 42 folds to reach the moon. Isn't that mind-blowing?
To understand the power of folding, let's visualize it in a simple yet profound way. Imagine a single sheet of paper, just an ordinary piece you might find in any notebook. We'll say it's 0.1 millimeters thick, which is quite thin. Fold it once, and it becomes 0.2 millimeters thick. Already it's doubled in thickness. Fold it again, and it becomes 0.4 millimeters thick. Notice how quickly it adds up.
Notice something interesting? Each fold is making the paper twice as thick as before. The thickness isn't just increasing, it's doubling with every fold. This is a perfect example of exponential growth. This doubling effect is the key to understanding exponential growth. After 3 folds, the paper is 0.8 millimeters thick. It's already 8 times thicker than it started. After 4 folds, it's 1.6 millimeters. The growth is becoming more noticeable. The numbers might seem small at first, but the growth is starting to accelerate rapidly. This is the power of 2 in action. Each fold multiplies the thickness by 2. With each fold, we are multiplying the thickness by 2, creating a rapid increase. This might seem slow at first, but after several folds, the numbers start to become very large, very quickly. Imagine if you could fold the paper 20 times, it would be over 100 kilometers thick. Now let's take our paper folding journey to the extreme, the moon. The moon is about 384,400 kilometers away from Earth. That's a long way. To make the math easier, let's convert that distance to millimeters, 384,400,000,000 millimeters. Remember our paper, starting at 0.1 millimeters thick? With each fold, it doubles in thickness. To reach the moon, we need to keep folding until the paper's thickness equals the distance to the moon.
How many folds would this take?
Without getting into complex equations, let's just say it's a lot. It would take about 42 folds to reach the moon. Surprising, right? But this is the power of exponential growth. Okay, time for a reality check. While the math is fascinating, we all know we can't actually fold a piece of paper 42 times and reach the moon. There are physical limits to how many times we can fold a real piece of paper. Try it yourself. You'll find that after about 6 or 7 folds, it becomes really difficult to fold the paper further.
It gets too thick and stiff. This is because of the nature of paper fibers and the limits of our own strength. So, while we can't physically fold our way to the moon, the thought experiment is still valuable. It helps us grasp the incredible power of exponential growth and its implications in various fields.
Section 5. The Unfolding Universe of Imagination. Even though we can't physically fold our way to the moon, the idea highlights something crucial: the power of imagination in science. Sometimes thinking about seemingly impossible scenarios can lead to real breakthroughs. Imagination allows us to explore the boundaries of what's possible. It's what drives scientists to ask questions, challenge assumptions, and come up with innovative solutions. The paper folding thought experiment, though fantastical, helps us visualize and understand a complex mathematical concept.
Remember, some of the greatest scientific discoveries started with a spark of imagination. So keep asking those what-if questions and let your curiosity lead the way. Section 6, Beyond the Moon, Exponential Growth in the Cosmos. The concept of exponential growth extends far beyond paper folding. We see it in the vastness of the universe itself. Consider the expansion of the universe after the Big Bang. The universe didn't just expand linearly, it expanded exponentially. Think of it like this. Imagine dots on a balloon. As you inflate the balloon, the dots don't just move further apart in a straight line, the space between them grows exponentially. This is similar to how galaxies are moving apart in our expanding universe. The universe is full of examples of exponential growth, from the birth of stars to the spread of light. Understanding this concept helps us grasp the immensity and complexity of the cosmos. Supernovae, black holes, and even the formation of galaxies all follow patterns of exponential growth. The cosmic web, a vast network of galaxies, is another testament to this phenomenon. From the smallest particles to the largest structures, exponential growth is a fundamental principle. Scientists continue to study this growth to understand the future of our universe. Will it keep expanding forever, or will it eventually slow down? These are questions we seek to answer. The journey to understand exponential growth in the cosmos is ongoing, and it reveals the true scale of our universe. Section 7, Folding into Other Dimensions. A thought experiment. Let's take our paper folding thought experiment a step further. What if we could fold not just in our 3 spatial dimensions, but in other dimensions that we can't perceive directly? This might sound like science fiction, but some theories in physics, like string theory, suggest the existence of extra spatial dimensions. These extra dimensions are thought to be curled up or compactified beyond our normal perception. While we can't test these theories directly yet, they challenge us to think beyond our everyday experiences. Could there be a way to fold through these extra dimensions, potentially leading to shortcuts across vast distances in space? It's a question that continues to intrigue physicists and mathematicians alike. Section 8. The Beauty of Mathematics, Unveiling Hidden Patterns. The paper folding puzzle, though simple on the surface, reveals the elegance and power of mathematics. Math is more than just numbers and equations. It's a language that helps us understand the underlying patterns and relationships in the universe. From the smallest atom to the largest galaxy, mathematics provides a framework for describing and predicting how things work. It's the tool that allows us to unravel the mysteries of the cosmos and make sense of the world around us. So, the next time you fold a piece of paper, remember that you're not just creating a simple shape. You're engaging with the fundamental principles that govern the universe. Section 9. The Paper Crane, a symbol of hope and precision. The art of origami, originating in Japan, takes paper folding to an entirely different level. From simple cranes to intricate dragons, origami demonstrates the precision and artistic possibilities of folding. It's a testament to human ingenuity and creativity. The paper crane in particular holds special significance in Japanese culture. It's seen as a symbol of hope, peace, and longevity. Folding 1,000 paper cranes is believed to grant a wish.
The delicate folds of an origami crane, achieved through precise mathematical calculations, remind us that even the simplest materials can be transformed into objects of beauty and meaning.
Section 10. From Origami to Spacecraft. The art of folding in science. Believe it or not, the principles of origami are being applied in cutting-edge scientific fields like aerospace engineering. The art of folding, once confined to paper and fabric, is now shaping the future of space exploration, proving that even ancient techniques can find new life in the pursuit of scientific advancement. Scientists and engineers are exploring ways to use origami-inspired folding techniques to design compact and deployable structures for space exploration. Imagine solar panels that unfold like giant origami flowers in space, or telescopes that compact down for launch and then expand to incredible sizes once in orbit. These are just some of the exciting possibilities being explored. Section 11. Keep folding, keep exploring. The journey of discovery continues. The next time you encounter a simple sheet of paper, remember its hidden potential. It's not just a blank slate, but a gateway to exploring the wonders of mathematics, the vastness of the universe, and the boundless possibilities of human imagination.
Keep asking questions, keep experimenting, and never stop exploring. The journey of discovery is an unfolding adventure, and there's always something new to learn, something new to fold, and something new to imagine.